Okay, this is homework, linear growth. This is problem number 1. Now this first one here, consider a population that grows according to the recursive rule. P sub n is equal to P sub n minus 1 plus 45 with initial population. P sub 0 is equal to 50. So I wrote my recursive form here of the equation in the explicit form. Okay, so the recursive form here takes the previous result and uses it to find the next result. And it's built into it so you can recognize it. In this case here, my P sub n minus 1 is equal to P0. When n is 1, P0 is going to be 50. And in this case here, my D is equal to 45. So you want us to find P1. So in this case, n is 1, so I have P1 here is equal to P0 plus 45. So my P0 is 50, and my D is 45. So I have to add these two together. So I come up here and I type P, and I can put a subscript here, and I can say P sub 1 is equal to space over the left arrow, right arrow key. And then I can go ahead and put equal sign, and then I'll have here what, 50 shift plus 45, and it gives me the answer there, 45. Then they wanted me to find P2, so I can say P, then I can type for my subscript 2 with right arrow key equals. Notice that when I did that, it was down. When I did the right arrow key, it came back up. Let me show you again. So then I hit the subscript here, and it went down a little bit, and I put in a 2. Then I can hit the right arrow key, and it went back up. I can put an equal sign. For P2, I'll have what's that going to be? P1, which is 95, the previous result, plus 45, shift plus 45, and it gives me that result there, 140. Then you want me to find P100. Before that, here, find the explicit formula. So explicit formula looks like this: P0 plus D times N. We found D to be equal to 45. In this case, my P sub 0 here is 50. Okay, and my D is 45, and I have N. So there's the recursive form there, and that's what I enter for my answer there. For the next one, I have here find P100. Okay, so P100 here, that means N is 100. So I can do P100 is equal to 50 shift plus there plus 45 parentheses times 100, and there's your answer there, 4,500 for that problem.